In today's lesson, we are going to look at graphing linear equations. So this formula, the y equals mx plus b, this is our standard formula or rule or equation that we've been seeing every time we've gone from patterns to algebra. Right? So when we were given a pattern or a scenario and we had to come up with a rule, it followed this form. And there are two key pieces for it, the m value and the b value. So we're just going to kind of review what those two values or variables mean. M, we talked about, was another word, was the multiplier. We also called it the slope. We sometimes call it a rate or a rate of change when we're dealing with certain word scenarios. But basically speaking, the M value is what it increases by. Right? So what the pattern, what the relationship increases by every time. The B value was our constant. We also called it sometimes the starting value or the base value or base phi. We also called it the Y-intercept because we talked about when looking for this on a graph, it was the Y-intercept. It was where the line crossed the Y value. So when we're graphing equations, we need to understand those two values or those two variables because we need to use them to help us figure out how to graph our line. So the key things that we want to focus on when graphing the line is we're going to use our Y-intercept and slope. So that M for the slope and that B value or constant for the Y-intercept. The first thing you're going to do is plot your Y-intercept. So you're going to find that value along the Y-axis and you're going to put a point there. You're then going to use the slope to determine other points on the line. And right now, all we're going to deal with is just whole numbers. So if we have a whole number, say for example, 2. So we say our slope is equal to 2 or M is equal to 2. As a whole number, it's 2 over 1. Or what we could say is, for every 1x increase, y increases by 2. So the bottom value or the 1 represents an x increase. The y value or the top value tells us how much the y value increases. So we've done this before in our patterns. Basically, this means our pattern is increasing every two shapes for every one position. So we've dealt with this before. The third step, once we've plotted other points, is just to extend the line, or basically connect the dots. So if I look at A, y equals negative 2x plus 3. So looking at my equation, I have my M value of negative 2, and I have my B value of plus 3. Again, the B value is the Y-intercept, so that tells me if I go up to plus 3 on my Y-axis, I'll have a point. That negative 2, this basically means down 2 every one move to the right. Or so basically every position increase, so if I go over to 1, my point is going, or my next point is going to be 2 down from the previous one. So if I'm at 3, that moves at position 1, I'm at 1. At position 2, I'm at negative 1. At position 3, I'm down 2 more, so negative 3. Position 4, I'm down 2 more at negative 5, and so on. This would also work in the reverse. So I could be saying down 2 every one move to the right, or up 2 every one move to the left. So if I go in the other direction, go back a position, I'll be up 2. Back another position, I'll be up 2, and so on. Once we've plotted these points, I can now connect them with a straight line, and that's how we graph our equation. Let's try it again with another example. If I look at b, y equals 3x minus 6. I want to focus on my equation, or my two values, so my m value and my b value. Again, I want to use the m or the b value to start off. So again, remember, we use the sign in front. So that's not just a positive 6, that's actually a minus or negative 6. So on the y-axis, I go over to negative 6 and put down a point. The m, it's 3. So that means up 3 every one move to the right. Or basically every one position, I'm going to increase 3. So position 1, I increase 3, I'm at negative 3. Position 2, I increase 3, I'm at 0. Position 3, I increase by 3. Position 4, I increase by 3, and so on. If I want to go in the other direction, because my line can go in the other direction, or basically reverse the pattern, I can do the opposite. So down 3 every one move to the left. So that means if I go back a position, I'm not at negative 6, I'm now at negative 9. I can't really go any further, so that's as far as I'm going to go. And again, I'm going to graph or connect, if I can, on them. Let me use a ruler, it's easier. I'm going to connect the dots with a straight line. And that's going to represent my equation. So again, we've dealt with this a bit before when we've graphed our patterns, or we've done the multiple representations. So this lesson is just a little bit of a more formal step-by-step process on how to graph an equation specifically.